So this next one, number 10, is a little bit tricky. There won't be one that challenging on your test, but we can still talk about how to do it. So when you're looking at this, it says you have a circle inscribed in or a triangle inscribed in a circle. So you might automatically think that you need to draw this shape, like so. And then that side's 13, it's isosceles, so this side is also 13. The altitude to the base is 5. Then you could do Pythagorean theorem and figure out that that's 12 and that's 12. Find the radius of the circle. So then you might think that you might do one of these bad boys, but time out for a minute because you don't know that this is really a special type of triangle and you don't know where this triangle is inside of the shape. So first, let's flash back to trigonometry. If we can know some of these angles, we might be able to figure out better how the triangle works inside the circle. So like if I want to find that angle right there, flash back to trigonometry, I would do the sine of theta equals 5 over 13. And then theta approximately ends up being 22. For our example, that's cool. So here, let's erase this. So if you think about inscribed angles, this angle goes with this. So if that's 22, then that has to be 44. And then these two there are the same, so this is also 44. So right away, this should seem like a red flag, because this is only 88 degrees, and you have drawn it so it takes up over half of your circle. Let's redraw. You really need this triangle to take up less than half of your circle, which is key, because if this triangle takes up less than half of your circle, then that means that your radius is not really, is just outside the circle, whereas how we drew it here, it was kind of inside the triangle. So we need to find the radius. So I'm just going to label that x, because 5 could be part of the radius. And then you need to figure out the rest of the radius. So I'm going to draw the radius in a more convenient spot, like right there. So if that's x and that's 12, this is also the radius. So this is x plus 5, because the radius is x plus 5. So you can do Pythagorean theorem, x squared plus 12 squared equals x plus 5 squared. And then it's x squared plus 144 equals, you got to do 2 of these guys. So x squared plus 144 equals x squared plus 10x plus 25 when you FOIL it all out. So the x squareds cancel each other, which is super cool, which means we don't have to factor. So we have 144 equals 10x plus 25. Move the 25 over. So you get 129. Sorry, 119. Then divide both sides by 10. So x should equal 119 over 10. Or you could say like 11.9. So that was kind of rough. Again, there won't be one like that on your test. So then this one, a regular hexagon with a perimeter of 24 is inscribed in a circle. How far is the center to each side? So first figure out each side. There's 6 sides, so each side is 4. And so then we can do that super exciting thing that we used to do, where we divide the shape up into smaller triangles, and then that height cuts your side in half to be 2. 360 divided by 6 is 60, which means that all these little triangles, the top angle is 60. And that 60 gets cut in half to be a 30. So you can do 30, 60, 90 triangles. I'll draw it out here so we can see it a little bit better. We want to know this is what we're trying to find. Remember, that's called the apothem. So remember your 30, 60, 90 triangles. which means this guy, x, is just going to be 2 root 3. Then the next one, we've got PB is equal to 3x minus 17. And CD is 15 minus x. And OQ and OP both equal 3. So those two segments are equal, which means they are equidistant from the center, which means that the two chords have to be equal to each other. So then I can add the x over here, and I can subtract the 17 over there. Oops, that's a 4. So x equals, oops, I added 17. So that's 20 or 32. So x equal 4x equals 32. So that means that x equals 8. So AB and the radius of the circle. So 3 times 8 minus 17 is 7. And then the radius of my circle. Remember, you always want to draw your radius in a convenient place. I'm going to draw it right there. If that's 7, this would be 3 and a half. So I can Pythagorean theorem, 3 squared plus 3 and a half squared equals r squared. Do all that super fun math, and we end up with 5 for my answer. Sorry, not 5. Do all that super fun math, and you get, this is 21.25 over, so switch that into a fraction, it's 85 over 4, and then you square root it, so you have the square root of 85 over 2. Next one. So find the perimeter of the sector. So the perimeter of the sector is the curved part, and then this piece and this piece. So if XOY is 45 degrees, and the radius is 6. So we got a 6 there and a 6 there. We just have to find the length of the arc. So fraction of your circle, 45 over 360, multiplied by the diameter times pi. Let's go ahead and reduce that fraction first. So 45 over 360 would just be 1/8 of the whole circle. And so then you have 1/8 of the circumference of the circle, which is 12 pi. So 1/8 times 12 pi. So again, practice your cross canceling. Makes life a little bit easier. They both divide by 4, so that's a 2. That's a 3. So you end up with 3 pi over 2. So your perimeter of the whole sector would be 6 plus 6 plus 3 pi over 2, which is 12 plus 3 pi over 2. And the next guy, we have a fly sitting on the midpoint of a wooden cord of a circular wheel with a radius is 10 centimeters. And the cord has a length of 12 centimeters. So it tells me how long this cord is. The cord is 12. Might almost be easier if I draw this outside the circle. So how far from the center is the fly? So ignoring all the little spokes, here's the midpoint. You want to find the distance to the center. That's what you're looking for. That's 12. Sorry, the cord is 12. So each piece is 6 and 6, and then we can draw in our radius because they tell us the radius is 10. Hopefully by now we know that's Pythagorean triple, and that guy would be 8. So it is 8 centimeters from the center. And then the next one, if you spin the wheel, how far does the fly travel in one rotation? So it's not really asking for the circumference of the wheel. It's asking for like how far the fly itself travels. So the fly is closer to the center of the circle than the edge of the circle is. So you would actually use this measurement you found right here. Your radius of your fly circle is 8. So your diameter would then be 16. And then your circumference of your circle, which is basically what you're finding, would be 16 pi. Since we're talking about a for real distance, it's not necessarily the worst idea to approximate that, which would be 80.26 when you multiply it out. But either answer would be acceptable. So then the next one, and the last one on this page, if AB is 7 and BC is 10 and CA is 11, find the radius of each circle. So the easiest thing to do here is to label one of the radiuses x. It really doesn't matter which one. So that's x and that's x. That one there, I would say, is 11 minus x. This one here is 7 minus x. This radius and this radius are the same. So that radius is also 11 minus x. And this radius is 7 minus x. So note this section right here. I have 7 minus x and 7 minus x have to add up to give me 10. So I'm going to do that. 7 minus x plus 11 minus x equals 10. Negative 2x plus 18 equals 10. Negative 2x equals negative 8. So x equals 4. That's one radius. The other radius is 11 minus 4, which is 7. And then the other radius is 7 minus 4, which is 3.